Okay, so we let's continue from where we stopped. So we have this question right in front of us. We have uh, a binary operation defined on b square, rather b square minus a square. So we have b square minus a square, and then we're told to find minus 3 star 2. Now obviously this is quite very simple. You don't need to waste much time there. This is first and second. So you go on to have your minus 3 star 2 being equals to first. Look at it. Oh, this was your first. This is your first being represented here. Oh. So this was your second. So second. So that will be 2 square. The second square, this is b being the second. 2 square minus 3 square over 2 minus 3 times 2. So this will obviously be what? 4 minus 9 over, this is 2 times 3. 2 times 3 being what? That will be 6 times 2, that will be minus 12. So this would be minus 5 over minus 12. This would be 5 over 12. I saw many of you writing your answer as minus 5 over 12. How did you get minus 5 over 12? Now, let's try and solve question number 2. Question number 2 there, we have it as half 1 over 2 star minus 1. Don't forget, this is first, this is second. So, and your second is what b was on the original function. So you have minus 1 square. So 1 over 2 star minus 1 will be minus 1 square minus 0.5 square over 2 times a is what? 1 over 2. B is what? Minus 1. So this will obviously be 1 minus 0.25, all right? 1 minus 0.25, that's 1 over 4, 0.25 over, we have these 2 cancels these 2, so we have minus 1. So this will be 1 minus 0. What is 1 minus 0.25? That will be 0.75, which is 3 over 4 over minus 1. 3 over 4 divided by minus 1 will be 3 over 4 times minus 1 over 1. So the final answer will be minus 3 over 4, which is minus 0.5. Does it make sense? Okay, good. So this question I was writing before the feed went out, and we have an operation defined on this a star b equals to 2ab. So you are told to find what the question said, what is the identity of the identity element? What is the identity element? So can you solve that quickly? Let me give you like probably just 2 minutes. What is the identity element? We have a star b being equals to 2ab. What is the identity element? So we're dealing with binary operation right here, and so the identity element, I want you to give me my answer quickly. It's quite simple, but I want you to make your attempt before I go on to solve. Okay, so the whole concept around identity element, I believe uh, you should understand this already. So this is the operation on which this okay, I think I see an answer there. I'm trying to look at the answer that I just saw. Okay, can you have, okay, let's see it together. So looking at this, let's make use of this. This will be A star E. So what is A star E being equals to A? What is A star E? Using this expression, that means A star E, first, second, A star E will be equals to 2AE. Alright? So 2AE. Now for this expression we have here, this particular expression, we know that 2AE then is equals to A, because this is A star E. So 2A being equals to A, we are interested in finding E, the identity element. That will be A over 2A. That will be 1 over 2. So E is equals to 1 over 2. The identity element is 1 over 2. Alright? Do you get it, young man? So that's the way you find the identity element. Let's run quickly on to the last aspect we'll be talking about under binary operation. So we want to talk lastly about inverse elements. All right, inverse elements. So look at now, we have a binary operation defined on this function, A star B being equals to A plus B plus 2AB. All right. Now you were told that the identity element with identity element being equals to 0. All right. So identity element is 0. So the question is, what is the inverse of element C? What is the inverse of element C? So this is the question. Let me give you like 2 minutes to solve this so we can jump to a different topic entirely. Okay, do we have an answer already? What's the inverse element C? Inverse element. Okay, now look at the whole concept around inverse element. So we have an element C. We're told to find the inverse element. I want you to know that there is also a notation, a syntax that says that when you have an element with its inverse, you must get identity element. This is something that also works when dealing with matrices. All right. So an element with its inverse will give you identity matrix. Does it make sense? So now, using this principle, can you try to find your answer quickly? So this is quite very simple. So this is the inverse you are looking for. You have your identity element C. So obviously, to get this, you need to go and fix this using the original expression on which it is defined on. So C star C inverse should give us E. That's the basic. This one is something you have to note. Just the same way you know that A star E or an element star, the identity element equals to the element. The same way you should know that C star C inverse, or you can also have it as A star A inverse will be equals to E. So these are two things you should note when you are trying to solve questions under binary operation. So knowing this now, of course, we're not dealing with A here, we're specific with the value of C, so we have to maintain the question C. That's why we're using C, not A. So obviously we have C star C inverse. Now, what would be C star C inverse? Let's go and fix this into our original expression. This would be C plus C inverse plus 2C times C inverse. That's based on the question. Right? This is something you can easily see. As I've explained already, you always come back to this original expression. So this is it right here. C star C inverse will be using this original expression. This is what it's the element, which is what we say E is, what it was. That's 0. So that means this is what we are solving. So by solving this now, we'll be able to get our identity element. Sorry, our inverse element. All right. So looking at what we have here, of course, we can decide to factorize. Let's bring what as C inverse to this side, and let's have this as minus C. So don't forget, our question is for us to find the inverse of element C. So it's C inverse we are interested in. So you want to go off and factorize C inverse. So that will be 1 plus 2C equals to minus C. Of course, here we have C inverse will be equals to minus C over 1 plus 2C. This is your inverse element. All right. So that's the way you solve questions on binary operation. These are very key things you must know how to solve if you want to be able to ace your exams. Does it make sense? Can I get feedback? Do you understand what we just did? Are you clear about it? Guys, can I get your feedback? So this is how you solve questions around. Okay, so good. That's good to know. So let's run to sequences and series. Can we go to sequences and series? Let's quickly run to sequences and series. Let's run to sequences and series. So we have the first question. You can obviously just, I would not be interested in wasting time in writing the whole question, so you can follow through. The first term of an AP is 7. The first term of an AP is 7. First term is 7. All right? And the last term of that same AP is 70. The last term is 70. And the sum of the series, now the sum of the series is 385. So the question is for you to find the number of terms in the series and then also finding the common difference. So you have to find the number of terms, and then also you have to find the common difference. So can we have 2 minutes in solving that? So the first term of an AP is 7, the last term is 70, the sum of the series is 385. You have to find the number of terms in the series, and you are also supposed to find a common difference. Can I get an answer in 2 minutes? Do we have an answer yet? Wow. So we don't have an answer yet. Okay, so let's solve appropriately. So I decided not to it's a very simple question. You're not supposed to use a long time in solving. So number one, I decided not to put the short so that you can, of course, first time we always time it as A, last time we time it as L. The sum of the series Sn was given as 385. So we're interested in finding N and D, common difference. From our formula of sum of the series, we know the sum of the series of an AP, we have, of course, we have two different formulas we can use, but when we are given the first and last term, the formula to use is n over 2a plus l. When we are given the first and last term, understand that it's not every time you will be using a plus l. So we have we have another formula we can use, which I'm sure you are aware of. So if you're not dealing with if you're not dealing with first and last term, this is the formula you use. If you are given a, if you are given d, and you know all these other things, if you know this is the formula we use when we're not given the first and last term. But when we are having the first and last term, we want to use this formula, and look at, we're given the first, we're given the last term. So this is what we're going to be using. We have been told that our Hessian is 385. So we have 385 equals to n over 2. We do not know our n. That was actually what we were told to find. And then we are told this is a plus l. That will be 7 plus 70. So this will be, I want to go on to cross multiply immediately. 385 times 2 should give me what? 385 times 2, a calculator there, should give me 770. So we have 770 equals to n. Let me just open this bracket already. That will be 7n plus 70. So 770 minus 70 equals to 7n. Is that correct? Good. So this is 700 equals to 7n. Of course, my n here will be equals to 700 over 7, which will be, n here will be equals to what? 10. Is it 10 or 100? Oh, sorry, I made a mistake in this. Is what am I doing? This is supposed to be 70n. That was a mistake, sorry. So I made a mistake there. So it's supposed to be 770 equals to 777n. Sorry, this was all wrong because I forgot to, they're the same thing. It's supposed to be 77n. So we have our n equals to 770 over 77, which is 10. So our n is 10. Alright? So now that I have gotten my n as 10, obviously it's quite easier now to finding my d. You say, why is it easier? Because once I know my n and I know my a, that's enough for me to find my d. The general expression for a particular term was given as what? It was given as a plus n minus 1d. This is the general, like if you want to find any term in the series, this is the formula for that. A plus n minus 1d, any term. So if you want to find the second term, the third term, you just say t2 will be equals to a plus 2. You understand that a plus 2 minus 1d, that will be a plus d. So, and so on and so forth. So at this point now, the best one to use is actually for me to use, because your first term is a, your last term is 70. Now, the number of terms we have gotten it to be 10, and that means already that my t10, which is going to be my last term, because number of terms, the total number of terms was 10. That was what we just found. We found that the number of terms was 10. That means our t10, which is the last term, obviously, if this is the total number of 10, will be equals to 70, right? So we know that our t10 was 70, based on this is the last term, and our n is 10. So in this case now, I can say my t10 is equals to a, I know my a to be 7 plus n minus 1, that will be 9 times d. And I know my T10 is 70. That will be 70 equals to 7 plus 9D. Alright? I'm sure you can flow with that. It's just making use of what you have and getting what you don't have. So if I do 70 minus, of course I have to go on to do 70 minus 7. That will be 70 minus 7 equals to 9D. That will be 63 equals to 9D. Our D there will be equals to 7. So our difference is 7. Our common difference is 7. That's how easy it is to find questions like this. All you just need to always do is to, you see, under sequence and series, the basis is your formula. You understand now that I saw this question. If this formula was unknown, there's no way you want to go anywhere. This first formula. So you use this formula to get your number of terms. Now, of course, you have to always know this formula also. This is another formula that is used to get the sum of terms, sum of the terms of a series.